Welcome to my channel WinChem. Today we are going to see a PGTRB Polytechnic TRB, some of the tricks in the C13 NMR spectroscopy. Okay, and we are going to solve some of the problems also. Okay, we'll see one by one. Check once again, 150 to 200. Okay, so the range always it's a coincide. What is the range? 176.8. This is the unsaturated carbon bonded to the oxygen atom. So C double bond O is 176.8. This is an acid. Okay, if you keep on watching these type of problems, if you solve many problems, we can easily come to know the ranges. Okay, and see here, this carbon which is having an alcohol, so oxygen is attached to the carbon atom, so it's above 60. Okay, oxygen is attached to the carbon is above 66, 66.6. The saturated carbon bonded to the oxygen atom. There is no double bond here, so everything is saturated. Okay, if double bond is there means unsaturated. See here, this is saturated carbon atom, not bonded to any oxygen atom. Okay, only CH3 is there, attached to the carbon only. So this CH3 is 19.9. See the first problem. This is the first problem. The first thing which you need to see is a symmetry is there or not. In this compound, symmetry is there or not, we need to check. This numbering, how many carbons are there, which are all the carbon is symmetry to the other carbon. For that sake, I have mentioned the colors. Okay, this is not this many signals. Okay, this is not mentioned the how many signals. Okay, we'll see the symmetry over here. If you see one acid is there, here also one acid, and two CH2 group here also attached to two CH2 groups are there. If you cut over here, this part will be symmetry to that another part. These two carbon are symmetry, and these two carbon are symmetry, and these two carbons are symmetry. The color shows the symmetry. We'll see the value for this. See, already I said the CH2 group, okay, the C double bond O group. C double bond O, just now we saw that. What is the range? Nearly 170. Okay, 170 is the range for this C acid group and this acid C double bond O. This acid C double bond O. And the next one, this acid C double bond O, this acid C double bond O. This is the symmetry over here. These two are same, these two are same, and these two are same. And the next one is a C2 and C5. And these two carbon atoms are similar. Okay, which is attached to the C double bond O. It's not directly attached to the oxygen atom. So it is slightly above. Okay, so it is 33.2. Okay, and the next one is these two are same. Okay, and that is 24 ppm. If it is if it is very only CH3 is there, means that will comes around 19. Okay, and then it moves upward, and then it moves upward. So according to that, according to the nearby atom, it keep on moving upward. The range will keep on moving upward. Question number 2. See, this is the another compound, heptane 2-one. Heptane 2-one. In this case, if there is no symmetry over here, okay, this color, that I am showing in this, these are all comes under a same range. It's not a symmetry. Okay, it's all comes under a same range. But the symmetry is over this C double bond O attached to this carbon also, this carbon also. So these two are looks to be in the same environment. Nearby carbon, this is also C double bond O is there. Here also C double bond O is there. So these two will come in the same range. We'll see that this C1 and a C3 will be 35 to 42 ppm. It will be in the same range. It's not a same peak. It's not a same signal, but same range. Keep that in mind. It's not same. It is a same. It's a nearby range. Okay, it's a nearby range. It's not a same signal. It's a nearby range. That's why I have mentioned as 35 to 42. This comes in between that range. And C2, this one I already said that C double bond O will come above 150. So above 150 to 200. 208 to 8 ppm. And C4, 5, 6, these are all in the same range. CH2, 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 and nearby also CH2 is there. Here CH3, this will be CH3 means we know that it comes around 13.9. Okay, less than 20. And above 20 means these CH2, CH2, CH2 is 20 to 30 range ppm. Okay. Next problem, question number 3. Ethyl benzoate has these peaks in its C13 NMR spectrum. That is 17.3, 61.1, 100 to 150. So 4 peaks are there in 100 to 150 and 166.8 ppm. Which peaks belongs to which carbon atom. You have to say which peak is belongs to which carbon atom. They said that's ethyl benzoate. Okay. You are advised to make a good drawing of the molecule before you answer. Okay. You just think about it. If it is 17.3 below 20 means that will be CH3 group. If above 60 means, so oxygen is attached to this carbon atom. Okay, oxygen is attached means it will be above only. Here benzoate, two oxygen atoms are there. That's why I'm saying its oxygen is attached to this carbon atom. And next one is 4 peaks are there in the 100 to 150. So benzene ring is there. In that benzene ring, 4 peaks are there in that to 100 to 150 range. Benzene ring is always having 100 to 150 range. And 166.8, we know that 166 means above 150 to 200, which is will be there. C double bond O will be there. So C double bond O carbon is having this signal. We'll see the answer now. See here. C double bond O is 166.6. That CH3 alone is 17.3. O is attached to this carbon, so 61.1. And all these benzene ring, which is having a 4 types of aromatic ring, that is 100 to 150. Why it is a 4 types of aromatic ring? Symmetry is there or not? Check here. In this aromatic ring, symmetry is there. If you if you cut in this way, you can see 2 similar CH2 group on both the sides. Okay. If you see these 2 groups, so this is also one, this is also one, but this is different, this is different. So you need to count these 2 also. So this we have these ortho is 1 and 2 meta is another 2. This is 1, 3 and 4. So 4 types of aromatic carbon is there. It's a 4 signal. This is the 4 signal. Okay. Only 4 signal you will get, because these 2 are same, these 2 are same, these 2 are different. Okay, that's why 4 signal of aromatic aromatic carbon is there. So that will comes around 100 to 150. This is self-practice question. Okay. In this question, how many signals would you expect in the C13 NMR spectrum of these compounds? Nearly 5 compounds is there. You need to check a symmetry of these compounds and you need to find out the signals of each compound. Thanks for watching. Subscribe my channel, click the bell button so that you will get upcoming videos. Thanks for watching. Share to your friends also. Thank you so much.